moving along with our trigonometric graphs, function graphs. Okay, today what we're going to do is we're going to be doing a few different things. The first, it might take about 3 videos to get this whole goal completed, but I can read and graph trigonometric functions and I can write equations of graphs. Okay, so numerous things going on here. So the first thing we're going to be looking at is what I call 5.3 Part 3a, which seems quite complicated. However, your textbook has ordered things a little bit differently. So what we're looking at today is horizontal compression and expansion. Okay, now if you can just see from this graph here, actually the lighter blue graph is a normal cos graph. However, the darker blue means that something has happened to the graph by changing it. You can see that it's changed its period. It's happening more often. And where that occurs in the equation is right in front of the x value. That tells us right in front of the x value what is happening to the period. Okay, so in our transformations, we had the value of b equal to +1. That's why we didn't see it in front of that x. Now, when b equals 1, we know that the period of all the graphs that we've looked at for sine and cosine has been 360 degrees. Okay, and then we go around the circle again and we get another piece of the graph again. So by changing that b, we're either making the period longer, and we call that expansion, or shorter, and we call that compression. And so the first thing we want to talk about here is period. You notice I have memorize. Very rarely do I tell you to memorize anything, but this is something that you should. So the period is always going to be 360 divided by that b value. So if I go actually back up to this graph up here, and I don't know if you can see that, I can actually make it a little bit larger for you to have a closer look at it. It says that the b there is 2.1. Okay, so, and if we look at this graph here, what happened when it was 2.1? Well, we have more periods in the same amount of space. So if I wanted to figure out exactly what the period of that darker blue graph was, is I could put 2.1 in for B. And so let's just try that here and see what we get. So you don't really have to copy this down. It's just to demonstrate what's happening. So the period on that one there that we just looked at would have been 360 divided by 2.1. And when we actually do that, we get, I'm not quite sure, I'd have to go pull out a calculator. So when we do that, what we end up is it's approximately 171.4, something like that. So you can see that it is increasing almost 2 times, a little more than 2 times in the normal period of 360. All right, so that's one piece of information that we need to know. So the next thing we're going to talk about is what's the difference in compression and expansion when we're talking about that B value. Well, compression occurs when we have B is greater than 1. So for instance, in this last example I showed you, it was 2.1. So what happened is it compressed the period in the sense that it took 2.1 less. Okay, so all the values have been multiplied. X values have been, important X values have been multiplied. And so it takes less amount of time to produce that period. And so that's what we call compression. Okay, and conversely, expansion happens obviously when the period is more than 360 degrees, and that occurs when we have the b value between 0 and 1. Notice b is not negative value, it's a positive value between 0 and 1. Okay, so let's take a look at what do I have to do then in order to graph it. So what's happening here, all the other transformations we've done so far, we haven't changed those important x values, you know, the 0, 90, 180, 270. Okay, so those are important. Okay, and actually that's short form for important. I believe it's short form in Latin, I believe. And what we're going to do is we're going to multiply those important values by the reciprocal of b, okay? Because it's going to take less amount, okay? And what we end up with are our new important values. So let's take a look at some examples. You can see how it works. It really isn't that too difficult when we're just putting a value here, not having a phase shift. That adds another dimension again. So first of all, graph y equals cos 3x and state the period. Okay, so first of all, I can state the period without graphing it, and I think I will, and then I'll show you how that works also. So let's get our pen up here, and we will do, I'm into green, so we're going to do green. So if we take a look at it, we know that our period equals 360 over b. That was what I asked you to memorize. So that's the same as 360 divided by 3. And when I do that, I end up with 120 degrees. Okay, so B is greater than 1, so we know that it's a compression, and we know that a period's going to happen every 120 degrees. So in a sense, what's happening here, I can fit 3 periods in what normally I would do. Okay, so I would take my values and multiply by the reciprocal. So in this case, I'm multiplying by 1/3. And obviously, when I do that all the way down, I end up with my new values. 0 times 1/3 is still 0. 90 divided by 3 or times 1/3, same difference, is 30 degrees. And that was 0 degrees. Here it's going to be 60 degrees. Then it's going to be 90 degrees. And 360 divided by 3 is 120 degrees. So if I take this formula and I also do this table, both of those need to match. And if you notice they do, both of them come up with 120 degrees. Now notice too that, since we're talking about this, that the spacing between here is every 30 now. Before it was every 90, now it's every 30. Okay, so it's asked us to state the period, which we did, graph this function. Okay, now, remember when we graphed before, we looked to see what was at the end, whether we had displacement. We don't have that, and our amplitude is still 1, so it's kind of normal that way. So I'm just going to pause it and make my axis so that it doesn't, you just don't have to watch me do it. So what I have here is my axis. Notice that I have made the x-axis purple because that's the one that's being affected here. Okay, our amplitude we talked about as being 1, so I'm 1 above, 1 below. And what I'm going to put on my x-axis this time are these important values. Now, one thing you do have to watch out for too is your ticks have to be evenly spaced. Now, obviously, because I don't have a phase shift, I don't really have to worry as much about that. And you'll see what I'm talking about when we actually do get to phase shifts. And so all we need to do then is, it's quite simple in the sense that we would do 30, 60, 90, 120, and we could keep on going, which I'm going to do, 150. Remember, there's space by 30, so I'm just adding 30 each time. 180. Normally, I'd only be half finished a period normally. And then we have a 210. I can also look into the negative zone if we so wish, so that would be negative 30, and I could keep going that way. Okay, so now I have my x-axis labeled, and I'm looking now to see whether I'm doing cos or sine. Now, in this case, I'm doing cos, so my ping pong ball has to start up on the highest point. And what's going to happen is these become my new important values. And so the ping pong ball now just fits in between there. So it's actually, as I said, it's not that difficult when you're just doing one transformation at a time. And now I'm just going to draw that with a nice smooth curve. And for the most part, you can see that it just looks like a normal cos graph if you just quickly look at it. Oops, that one's off a little bit. Oh, that'll teach me to get rid of the whole thing. And just so that you know the difference, I'm going to put the normal one also on top of it. Okay, arrows, it goes in both directions. I need to erase that little boo-boo there. And if I do the normal one, and I will do it in black just so that you have a contrasting one to look at. Normally coast is here. It doesn't come down until 90, and then it reaches the bottom here. So they reach the bottom at some point the same. Okay, and then I come back up. So you can see when I put the normal coast graph on, it does look very, very different from this transformed one. All right, so let's see if we can get another couple done. All right, the next one. Okay, this time they've changed some other things for us when I'm looking here and here, but again, I'm interested in what's going on for my period. So this time, when we're figuring out our period, again, we're doing period is going to equal 360 divided by the 4, and 4 goes into 36 9 times, so our period is 90. Again, we're compressing it. The period, we're fitting 4 periods in where we normally did the other, so we're multiplying this by 1/4. Okay, so we end up with 0. 90 divided by 4, so you're looking at, sorry, my brain's not thinking, what, 22.5 at here, it's going to be 45, I believe. Then, because we have to have 90, then we end up here as 4. Divide that one by 4, so we're looking at 60. Don't you love me calculating in my head? 32.5. Just hold on. I'm going to check this to make sure I did it right. Just what I thought. I knew there was one that was wrong, and it's this one here. It should be 67. And so that should be 67.5. Now when you look at what we're going to have to label our x-axis, we're going to have to do a little bit more work here in some respects. So each tick, we could make it 22.5 if we wanted to, and that would work because the spacing between all of these is 22.5. All right, so again, I'm going to stop the video, draw my axes, and then we'll talk about where all the lines go. Okay, so again, what I've done is I have created the axes. I've actually transferred these values here. Okay, notice evenly spaced every 22.5, so you could keep on going as well. I just got lazy and didn't put them. In generally speaking, unless they tell you to, you need to show at least one full period labeled on the x-axis. Okay, so now let's go and finish graphing this. Okay, so I have a displacement of -1. So we'll do that in green. My amplitude is 2, so I need to go up 2 from that, so at 1, and again at -3. I then look to see if I'm doing sine or cos. I'm doing sine, which starts in the middle. So that's the next thing that we'll do. And it starts, oops, I don't want that one. It starts in the middle and goes up. So again, you can see that it's not really that difficult. Okay, after you do those, but remember, it's all of them are going to look the same. The only difference being is how you label that x-axis. So if you don't label it, obviously you're not going to get any marks for that. Okay, so it's really important to have that labeled. Okay, and that one is off a little bit. I'm just going to erase it to make it go where I want. And so you can see that it's as I said, it's not that difficult. So it looks pretty good. Okay, not going to have enough time to get this last one in, but I do want to do it because a couple things going on. One being b is less than 1, and also we have a negative in front of that cos.